Hello students, today we will study about the chapter Earth's structure. You have already studied about the three realms of the Earth, lithosphere, hydrosphere and atmosphere. Today we will study about the interior of the Earth and its composition. The change in temperature, pressure and density in the Earth's interior with increasing depth can be estimated from velocity of earthquake waves through the Earth and by studying lavas emitted from volcanoes. Let us learn about the thermal or the temperature conditions of the interior of the Earth. As we go down below the surface of the Earth, the temperature goes on increasing at the rate of 1 degree Celsius for every 32 meters of descent. The thermal conditions of the Earth may be summarized as follows. At a depth of about 48 km, the temperature is about 1200 degrees Celsius. The temperature at the depths of 400 km is about 1500 degrees Celsius. The temperature at molten outer core and the inner solid core at the depth of approximately 5100 km is estimated to be about 4300 degrees Celsius. The pressure exerted by the weight of the atmosphere inside the Earth has also been used to determine the composition and structure of the Earth's interior. At a depth of 2500 km, the pressure is estimated to be about 3.5 million atmospheres. Now let us talk about density. The average density, that is the weight per unit volume of the Earth, is 5.5 gram per cc. Now let us learn about the structure of the Earth. It is believed that the Earth is composed of three parts: crust, mantle, core. Now let us study about each part in detail. Crust is the uppermost layer of the Earth. It is also known as lithosphere, which means the stony or rocky crust. It has two parts: continental crust and oceanic crust. An average thickness of the whole crust is 6 to 48 km. It forms less than 1% of the radius of the Earth. The temperature of the upper part of the oceanic crust has been estimated at 0 degrees Celsius, but it gradually rises towards the interior. The weight and pressure of the rocks also starts increasing with depth. The crust is again divided into two parts: Sial zone and Fema zone. Sial floats on Fema. Now let us study about Sial zone. The outer lighter part is the upper crust or the Sial zone. It is the continental crust. Its density is 2.7 gram per cc. It consists of silicates of aluminium and is also known as granitoid layer because of more of granite in it. It is a discontinuous layer. In Sial, Si stands for silica and Al stands for aluminium. Now Fema zone. The lower part of the crust is Fema zone. It is the oceanic crust. Its density is 3 gram per cc. It consists of silicates of magnesium. Unlike Sial zone, it is a continuous layer. In Fema, Si stands for silica and Ma stands for magnesium. Unlike Sial, it is a basaltic zone as it mostly consists of basaltic rocks. Now let us talk about mantle. It lies below the crust, that is lithosphere. Its exact position is between lithosphere and the core of the Earth. Its thickness is 35 to 2900 km. Mantle is the second layer of the Earth between the crust and the core, with its upper boundary marked by Morovicic discontinuity and its lower boundary marked by the Gutenberg discontinuity. The contact zone of the crust and the mantle is called Morovicic discontinuity, or in short we can say Mo discontinuity. In the same way, Gutenberg discontinuity is the contact zone of mantle and core. The mantle is divided into two parts: the upper mantle or asthenosphere, which extends from Moho discontinuity. to a depth of 200 km. The lower mantle or mesosphere extends from 200 km to 2900 km.